Yeah. We have to split this into H plus HSO4 minus. But, you know, the situation is we don't form sodium. What's this ion called? This one on the right. This one's called bisulfate or hydrogen sulfate. We didn't form sodium bisulfate. Instead, we formed sodium sulfate. And so what about this last H plus? Shouldn't we also remove that last H plus? And the answer is no. We have to leave that last H plus there. The reason we have to leave that last H plus there is because this is what we expect to find in the beaker. This is H2SO4AQ. If I have a beaker full of H2SO4AQ, then what happens is water is strong enough to pull off the first H plus. So we'll end up with H plus or hydronium. But is water strong enough to pull off the second H plus? It turns out no. You know, remember that tree analogy I tried to do? You know, what's happening is water is not strong enough or tall enough to reach all H pluses. It's a big tree, so it can't because it's a weak acid. And therefore, water is not strong enough to pull off that second H plus. But water may not be strong enough, but sodium hydroxide is plenty strong enough to pull off that second H plus. And so that second H plus happens because, you know, what we're looking at in this is what's in this beaker. And then when we're looking at this, what's in this beaker here? So this would be, what do we call this? Is this a strong base or is this a soluble salt? I call it a soluble salt because it's a group 1 compound. And so soluble salts will break apart into the ions. So it breaks up into 2 sodiums and 2 hydroxides. And so in water, this lattice is broken apart to make sodium ions and hydroxide ions. It was an ionic lattice, but water is enough to tear apart that ionic lattice. Now, the second hydrogen in sulfuric acid comes off when I mix these 2 beakers together. When I mix these 2 beakers together, then we have a strong base. That strong base is hydroxide. That strong base hydroxide is plenty powerful enough to pluck all the hydrogens off the HSO4 minuses. And so it's a little bit of a sequential thing here. Yeah, we only break this up because this is only exposed to water. And so this is why we have this like this in the ionic equation, even though we reacted all the way to sulfate. It's just when we mix everything together, then we're going to end up with 2 waters. Do I ionize the waters into hydrogen ions and hydroxide ions? No. It's not a strong acid, it's not a strong base, and it's not a soluble salt. So if neither of those, we'll leave it alone. How about sodium sulfate? Well, all sodium salts are soluble, so we break it apart into 2 sodiums and a sulfate. Is this what you guys got? Yeah? No? All right, so now everything's mixed together. With everything mixed together, then we end up with water molecules, so we'll have some more or additional water molecules that form, and sodium ions and sulfate ions. All right, what's the final step? What do we do? So what would you get? If you got this as your ionic equation, what would you get for your net ionic equation? Okay.
Just leave out the water.
I'm sorry?
Would you just leave out the water?
We have to leave the water in there, otherwise it doesn't balance. If we're to remove the water, then what happened to the hydrogen and oxygen? There's no hydrogen and oxygen over here, so the water has to be in there to make it balance. The only thing we can get rid of are the things that are the same on both sides. If we can get rid of the same on both sides, then it just cancels out. Nothing happens. So what stayed the same on the left side and the right side? Did the H plus? I see H plus over there on the left. Do I see H plus over here on the right? No. HSO4 minus. I see HSO4 minus on the left, but I don't see it on the right because on the right I have SO4 2 minus. They aren't the same thing exactly. And so I can't cancel those out. Over here on the left I have 2 sodium ions. Over here on the right I have 2 sodium ions. I just missed one. And so the sodium ions don't change, so I can get rid of those. Here, they're spectators. And the hydroxide ions did change. I have hydroxides on the left, but I don't have hydroxides on the right. So on the NIE, I'm going to have this. I'm going to have H plus HSO4 minus plus 2 hydroxides. I'm going to yield 2 waters plus a sulfate. That would be the NIE. Okay, we'll do one more here. Okay, why don't you try this one? Sodium fluoride plus phosphoric acid. Give you a